Okay, so first of all, this presentation was originally designed to kind of speak to executives, and so I've kind of gotten dumbed down on a lot of things, but hopefully you'll get some value out of it. And so I'm not going to get into too many technical details, but kind of try to drive it from a business perspective, and it seems to fit kind of the business track. So one of the things that I do is there's a kind of common rule for speaking that you should have about 20 slides for about 20 minutes or some ratio like that. Right? I don't know what it is. I have 200, and so we'll slam through these things pretty quick. But don't worry, it's not going to be that bad. Okay?
Will you post them?
Yes, I already posted them. It's on SlideShare.
Awesome.
Okay. So, and I'll have a link at the end. Okay. So what I want to talk about is really 3 problems. Well, actually, a problem, 3 misconceptions, and kind of 9 rules to how to get around that. Right? And the problem is well, it starts out pretty simple. Every day we have thousands of developers writing millions of lines of code all around the world, every single day, right? But there's one really interesting problem with all that code, right? Anybody want to venture what that problem is?
Humans?
Kind of. We're really close on humans, yeah. It's this. Right? Who hasn't seen this curve with a project? Come on. Who hasn't? All right, everybody sees this, right? So this is the thing, is my team, they write a lot of this code. Okay? We write a lot of code, honestly, this crap, right? But that's not their job. Okay? Their job really is looking at something in a little bit of a different light. Looking at data, looking at code in a different way. And so what their job is to look at code, not from this perspective, because code is just text, right? It's really all it is, right? Compiled code is just a bunch of words, right? This is the first misconception. Writing code is the most important thing to do. Anybody want to agree with that? I'm going to say it's not, so does anybody want to agree? Okay. So what is it about code that really matters? Okay. Well, this is one way to look at it. In a lot of ways, we write a lot of bad code. It's sort of like the anti-matter, anti-pattern same thing, right? If you want to look at our code repository, right, that's the dark matter. We don't want to go into there, right? And honestly, much of the stuff really doesn't even matter, okay? I'm seeing heads go up and down, so you guys kind of agree with this. So this is the point. Running code is what matters, okay? But running code in production is what matters a whole lot more. Okay? So misconception number 2, okay? Bug-free code is important. Quality? What's quality? How would you define quality?
Working product.
Working product, that's a very common one. Any others? Okay.
Robustness.
Robustness, very good. My simple 2 rules for quality are this. Number 1.
Yes.
Okay. Really? Isn't this it? Right? Yes. Isn't this what we're after? Okay. Anybody want to disagree with this? Okay, good. Okay. So anybody can write lots and lots of bugs, right?
Yes.
I do often. I wish it was this way. I'd be rich. I really would. Okay? So, here's the thing that matters, right? People using your software. That's really what we're talking about that matters here. Right? If we're talking about quality, we're talking about things that don't piss people off. Because they matter. That's more important than your code. That's more important than the number of bugs you find. And that's more important than the number of bugs you find. Okay? So misconception number 3, quality. Quality is value? Yes? No? No. Quality is not the same thing as value, right? So what is value? Now we're starting to get to the heart of this, okay? Well, more specifically, what is business value? What is it we're providing out to our users, to people? Okay?
Service.
This can be a service. In a lot of ways, that's the most accurate answer you can find. Thank you. So business value is anything which makes people happy. What a weird metric, happy, right? Developers don't like that. They can't quantify it, and they really don't like it. But think about it, okay? How many times do you use software and you like it? How many times do you use software and you don't like it? Isn't that just happy or not happy with it, right? Can you quantify it? No. But does it matter? Yes. Do you know where you can quantify it? Dollars, revenue, sales. Okay, we want happy customers. Yes? Yes? Yes, we do. Okay, so happy customers are happy not because your code is bug-free or because your code works. Happy customers are happy because your code works for them.
Look at Windows 8.
Look at Windows 8.
People hate Windows 8.
They absolutely do, right? There's other operating systems.
It works.
Yeah, it works.
It's more or less bug-free.
It's more or less bug-free. You're right. It's more or less bug-free. They have thousands of developers working on it, and it is more or less bug-free. It's pretty close to pretty solid code, but
No one likes it.
no one likes it. Okay.
I do.
That was awesome. Thank you. Who said that?
The guy with the Mac.
The guy with the Okay, so what we really want is we want to generate value by creating happy customers, right? They're happy because they like what we give them. So let's actually talk about why it's important to us. Well, it's pretty simple. We want to be employed and we want to stay in business. Okay? So this is where an interesting intersection between the business and technical world actually meet. And they actually agree on it. We just don't necessarily all speak the same language. So I'm going to try to put this all into context and speed things up a little bit. So happy customers give us money. Business, when they see this, when the executives see this, all of them, their heads are going, yeah. It's sort of like this nirvana state, right? But we have happy customers or we have a problem. It's that simple. It's yes or no. Engineers like this. It makes a lot of sense. So, my money, my rules. Here's my 10 rules. Okay? How do we keep our customers happy? First of all, this is what most developers look at. I'm going to start my project, and it's going to be awesome and perfect until I finish it. Right? But the truth is that finish they're talking about is right here. This is when you ship. This is when you're done cutting your code. Unfortunately, as soon as you're done cutting your code, you fall off into this pile of rocks, right? And then you climb back out of the hole of despair and somehow make it over to the next, and then you have to climb again, and then jump sharks with lasers. And you keep doing this over and over in time. But the interesting thing, this is where we ship, this is where we finish. Between here and here, you either have happy customers or mad customers. Okay? So, first thought for developers is when you ship is when things start. We'd like to say that's when we're done. No, that's when the game actually begins. So how do we get to this finish line? Well, first rule, don't piss people off. Okay? Don't piss people off with a slow site. Yeah? Or an ugly site. I write lots of buoys, but ugly user interfaces. Now I have to talk to the designers that I work with. Yeah, they don't like what I do. I like green screens and stuff, right? But ugly sites, users don't like them. But users also don't like pretty sites. Okay? Sometimes it just gets in the way, right? Great user interface design and concept, but it makes it very difficult to use Windows 8. Okay? Rule number 2, monitor your code in the wild. Okay? This is a conversation that's going on between you and your customers. But if you're not monitoring it, you can't hear it. And the reason is our code generates business value when it runs. Yes? Okay. Not when we write it. Big distinguishing difference. Okay? We didn't know what our code does when it runs. Okay? Because you may not really know what you think you do, but you really don't. I'll explain why in a minute. Okay? And we can't do any of this unless we measure it. So why measure it? Okay? Rule number 3. We don't really know our code until your code runs. So in a lot of ways, this is kind of looking at the difference between a map and a territory, right? We have a map of Provo, Utah. I can show it to you. But if you live here, if you've gone to school here, if you spend any time here, you know that the city of Provo is a very different thing than the map of Provo. Right? The way we talk isn't necessarily the way things are. The thing we think of isn't necessarily the thing in itself. Let's explain that a little more. Perception is not necessarily the same thing as reality. Right? I literally had a manager one time that stood up in front of us and said, it's my perspective and my perspective is reality. Right? He didn't last long because nobody stuck around after that. Right? Because reality does matter. Reality is what you experience. This is the area where happiness comes from. Your perception is what you think is going to happen. Okay? We have a mental model of our software. We have a mental model of our systems. We have a mental model of our business model and our customers. But that's not necessarily the way thing is, right? We have a mental model of our code. But that's not the code. Okay? It's a mental model. And it's often really, really, really wrong. Okay? Often this is how we look at our code. Yep, it works. This code is fine. My code works on my machine. That code can't do that. Whoa, it shouldn't even do that. How did it do that? How did this ever work? Okay, I get it now. I've done fixed it. And then we start this cycle over again. Right? Who's been a part of this cycle? Admit it? Yeah. We all have, right? But when we talk about this code can't possibly work when you ship it, sometimes it actually works. Okay? This code can't possibly fail. How many times have you heard fail to say that? Right. It fails. Absolutely. Right? So debug this one. Which one is faster? This line, a sort by, or this one? Which one's faster? A or B? We don't know. Okay? And the reason you don't know is sort by actually has this fun little sleep that the disgruntled employee put in there. 100 milliseconds. I slowed the whole thing down. Could you imagine what this would do to your site? Right? But is it any less catastrophic than this one?
Oh boy.
Okay? So we really don't know, and we don't know until we measure it. Okay? Hopefully you'll catch code like that through code reviews and check-ins and other quality measures. But it's an example that you really don't know what's going in your code when your code becomes deep. It's very easy to look at 1 or 2 lines or even 10 lines of code. But when you have 10,000 lines of code that it travels through for one request, do you really know? So rule number 4, make hard decisions by using metrics. Okay? I'll be honest, management doesn't like this. I've seen this over and over and over again. I want to go based on my gut. My gut tells me this. I'm all for intuition. It tells you where the mark is before you even know where it is, right? We're following the puck. But if we have hard metrics, it's going to change your perspective a little bit. And here's one example. Our application is slow. This page takes 500 milliseconds to fix it. Well, 500 milliseconds. Go fix it is what they're saying, right? Right? So here's the problem. I want you to go find this bottleneck, right? Is it my SQL queries? Is it my template rendering? Or is it my session storage?
Or is it the user's connection at home?
Could be that too, right? But we're going to measure only what we can measure, right? And we don't know, okay? Unless they have Google Fiber, maybe it isn't them.
Yeah.
Okay? So here we're going to look at it a different way. My SQL queries take 53 milliseconds. My template rendering, which is where I bet my problem is going to be, actually takes 1 millisecond. So it's not bad. But my session storage takes 315. Yeah, I think I found a problem. It's right there. Right? This is metrics I can make a decision on. Clear, clean, crisp metrics. Okay? So we improve our mental model by measuring what our code does. So this is where a map does not equal a territory, but a map can become our territory. Does that make sense? Good. Okay. This better mental model actually helps us generate more business value. Right? And so this takes us to rule number 5. Know your code's business value. Okay? That's boring. how do we measure that? How do we measure business value in code? Well, this is going to take us to rule 6. If it could affect your code's business value, stick a metric on it. If you think it could affect your business value, stick a metric on it. If you have a gut feeling it could, measure it. Just measure it, right? Good rule of thumb, measure everything, okay? It's easier to find out what you shouldn't measure after the fact than not knowing what you should have measured before, okay? So we're going to look at gauges and counters, meters, histograms, and timers. These are great ways of measuring the code. Gauges is a really useful one. It tells us right now what our code is doing, okay? For example, the number of users, okay? This site has registered 94 new users in the last 24 hours. This tells me a lot of information right now, right? Can I act on this? Maybe. I need some more information, but this is a very valuable data point. Okay? Counters. Counters are increasing and decreasing the value. Right? They go up and down. Right? This is another data point. The number of active shopping carts. Right? Now is it starting to become more useful? Yeah. Okay. There are 842 active shopping carts worth $1.2 million. Is this useful business value information? Oh yeah, right? Look at that number, right? What if it's going up? What if it's going down? What if it's going down fast? Not through sales, but through canceled shopping carts, right? It tells you a lot. Meters. The average rate of events over a period of time, okay? This is very common. This is the one most dev offshoots, right? Number of requests in a second, right? This is actually how I would say 90% of the people out there measure these meters is using number of events over last time, okay? And if we look at our numbers, and they kind of in a splattered plot look like this, do you see a problem visually?
Yeah, it went down, then it jumped and jumped again.
What happens if this is over a wider time frame, or there's more data points? It's harder to tell, right? It looks like this mathematically, right? But it's missing a very obvious gap. See, so if we go back to our calculation, we realize this is completely wrong. The easy, simple solution, of course, is exponentially weighted moving average. And of course, all of us understand is this algorithm right here, this mathematical, right? Any questions on this? No, none at all, right? And by looking at this, you know exactly that the most important thing about this is, of course, that. Does this make sense to anybody, really? No. Yeah, it takes a math, but this is where understanding how to measure things is becoming very important, right? So now if I look at this same graph again, using an exponentially weighted moving average, I actually see that there's jumps, right? But they're pretty wide, and so I've actually covered a lot of noise, but I've also covered a lot of valuable information. So I'm going to restrict it down a little bit. Tells me a lot more information. I'm going to restrict it down a lot more. This tells me a lot. Look at the gap from here to here, or from here to here. That's a lot more telling than even just looking at it naked, or with your moving or original moving average. Right? This is now very valuable information to use. Lots of data points. Right? We're looking at 1-minute rates, 5-minute rates, and 15-minute rates. And it's important to see it on different time scales over time, because it gives you different perspectives, right? It's like driving down the freeway at 85 miles an hour versus driving down a side road at 25. You see things differently. Hopefully you're not driving 85. Okay, maybe 80. So we went from 300 requests a second to less than 500 a second. This is the kind of information you can get out of these kind of graphs. Now we want to apply histograms. Histograms is actually one of the most underused, or probably one of the most valuable metrics for DevOps. A statistical distribution of values in a stream of data. Okay? Number of product listings returned. Minimum, maximum, mean, and standard deviation. This is kind of the golden four that we use. Okay? But the problem is it can generate huge amounts of data. Right? So much data that you're not going to actually be able to collect it all. So we're going to do something else called reservoir sampling. we're going to take one of those time periods and just take a time slice. What does it look like now? What does it look like now? And we aggregate those off into different segments. 5 minutes, 10 minutes, 15 minutes, 30 minutes, even up to days or weeks or months. Okay? So now when we look at our data, we can look at it kind of like this, right? We've basically taken that same data representation we had, we normalize the bottom of it down. If anybody gets lost, we can talk about this later. And then we take a look at the same histogram over time, and it looks nice and flat there at the bottom. But if we look at it at a different time scale, 15 minutes, we see those two same jumps that we saw earlier, right? But now we're seeing it in a very different way, because now we can say 17% of our shopping carts resulted in a completed sale. 17. Is that good? Is that bad? We don't know, right? So now we have to look at it another way, timers. A histogram of durations and meter of calls. Now we're bringing all this data together, and we're looking at it from multiple perspectives. Remember, your math isn't necessarily what you experience. You need to be able to understand it from multiple perspectives to see what's going on in your systems. Number of milliseconds to respond. At 200 requests a second, our 99% latency jumps from 13 milliseconds to 453. Okay? So now knowing that, if I go back and I look at this, what does that tell me? I'm slowing down. I'm slowing down. What's next?
People run away.
People run away, and what do we have? Pissed off users. Okay, so let's jump ahead again. Rule number 7, place current values in historical context. Okay, and how do we do that? Pretty simple. Observe, orient, decide, and act. This is a very fundamental idea that actually comes out of the military. The way we look at that is we're going to observe what is the 99% latency of our checkout page. Okay, about 500 milliseconds. Okay, how does this compare to other parts of our systems? How does it compare today? How does it compare to last week or last month? How do we see things changing? And that's what we're looking for. Change is actually really, really good. We want to see things change in a positive direction, but sometimes the change in a negative direction tells us a change in user behavior we can actually capitalize on. So it's very useful information. And in this context, we know it's way simpler. So is this bad or good?
It can be good.
It can be good. In fact, in this case, it's really good, right? The reason it's good is because we actually see more users on our site. But the more users on our site is causing our latency to go up, which is slowing our site down, which is pissing off users, including new users. So how do we resolve that? Beef up our systems, right? It's not a problem with our system, it's a change in user behavior. On one side you have your code on your servers, and the other side you have users. And when the two meet, things change. And being able to predict, analyze, and understand that change is what drives these kind of decisions. Okay? So now we have to decide, should we make it faster, or should we add feature X? Okay? Maybe we should make it faster. Okay? I have a rule for all my developers, right? One rule says is the place we want to be is adding new features, adding new functionality. That's where, as developers, we get the most pleasure. We like doing that, right? But maintain and sustain operational effectiveness is more important than new features. What's more important than that is critical 911s. We don't want to be in the critical 911s. We want to be in the new feature game. But it's always a competition between where you go with your customers pushing you in one direction versus your developers wanting to stay in another direction. Knowing how to deploy becomes very important. So being able to make a decision like this seems trivial when it's on screen, but when you're actually faced with it, it's a lot harder. Use data. Having this data behind you, these basic stats, makes these things very easy to decide on. So act. We're going to write some code. Okay? So that's all fun and dandy. But what if now something seriously goes wrong with our system? What if we didn't monitor it and watch those things and we actually went over the edge? We got into that 911 I wanted to talk about, right? Rule number 8, identify your exits. First of all, I have an escape plan. Okay? And that escape plan includes alerts, an outage plan, escalation plan, a recovery plan, and one of my most favorite tools, post-mortums. Alerts. Simply phrase alerts. Okay? This will happen in 1 in every 1 million transactions. Okay? What does that really mean? In one context where a company was at, there's about 5 times a second. Right? 5 billion transactions a second. So if we introduce code and problems that happen once every 1 million times, which seems pretty rare, it actually was very frequently. Knowing your metrics will help you identify that. This is going to cost us 3 months of development time, or $500 a second while the system is down. Real numbers. Okay? As you're counting those away in the back of your head, and you're having this argument with your developers, it changes the game, right? I know it's not the perfect way to write code. And sometimes that's okay, because if it's dumb and it works, it's not dumb, right? If your customers are unhappy because of your perfect code, that code is dumb, right? But if you have dumb code that your customers like and you're avoiding something like this, that's great. Can you go back and improve it? Well, yes. How should we improve it? I'm going to go all the way back to my metrics. I'm going to look at my numbers and see how we can carry that forward. Our servers have plenty of capacity. I've heard this a number of times, right? And
bandwidth.
you look at bandwidth and they look at it and say, you're not even using close to 80, you only use like 5-10% of your CPU usage. The I/O is pretty low, it's maybe 10-20%. And then all of a sudden the weekend comes around and you have 500% increase on that. And all of a sudden all your I/O is slammed, right? What's happening on the other side of that server? Yeah, it's not using. Okay? Again, nothing about this is really about the quality of your code. It's really about the experience of your user. Okay? So when we have these kind of problems, we want to raise alarms. This is our outage plan, right? The site is down. I had an experience once where I actually had left a company to take another job, and I got a call at 3 in the morning about 2 months later from my previous job where the VP was saying, hey, Dave, can you help us with this? Our system's down. I know you're no longer a part of the company. Yeah, sure.
$400 an hour, 4-hour minimum.
You know what? I said a joke like that, and he says, I'll take you to lunch. I still have to get back out. It's okay, I'm still good friends with him. So escalation plan. This is an underutilized tactic, right? A clear plan of action makes a big difference, right? Knowing what to do when you're in trouble is something you should practice and understand before you get into trouble, okay? So, I'm going to give you this story. Let's stop for a second. I have a little more time we can do this. I used to be really into paragliding, right? The big wing over you, you get to go off and do it over the Point Mountain. And I spent a lot of time on ground control, right? Where it's not like ground control like an airport. You're sitting there flying your kite, and you're learning how it works in the wind, right? And then you practice maneuvers and you challenge. Well, there was one time I was doing a really, really dumb move. I went upside down. I fell. I fell past my wing, and my wing collapsed, right? And now I was falling. And an interesting thing happened is all of a sudden I went into, oh, I've been trained for this. I know what to do. I have about 5 seconds before I hit critical velocity, and I'm not going to be able to recover. And then I'll crater. Plenty of time, 5 seconds. About 4 seconds done. First decision's made. All right, relax. Okay? Pop your wing. So I pop my wing. Popping the wing is pulling on your brakes in a certain way to try to get the wing to recover. That didn't work. 3 seconds. Next move. All right, go in hands up. Hands up is basically letting everything go and letting the wing try to recover on its own. These things are well designed, so very well could recover on its own. Pop. 2 seconds. That didn't work. All right. I have my reserve. I grab my reserve, throw my reserve, that thing pops about a second and a half later, and now that one's off. I have a parachute that's bringing me down safely. My wing recovers, and now I have 2 bringing me down safely. and I hit the ground, and all the adrenaline hits. I just start shaking, right? The funny thing is that kind of experience is the same kind of cerebral experience I have when we get into an escalation problem. Right? It's the same thing. You know you have a limited amount of time, but your training kicks in. You know what to do in 4 seconds, 3 seconds. Oh, just wake people up, 2 seconds. All right, let's open a call, let's get all the DBAs online, 1 second. All right, we found the problem, we have a solution, 0, we got a recovery. You start shooting. I've seen all of my developers do that when we get into this, right? The way you get in and survive this is have a plan. Okay, questions? Good. This is my plan. Number 1, have an on-call duty manager in place, right? An on-call duty manager has one job and one job only: coordinate and communicate. They do not get involved with the code. They do not get involved with the actual decisions of what is being done. They coordinate the effort. This is the person that calls out, do we need a DBA on the line? All right, I'll get them on the line, right? It's been 5 minutes, do we have a solution? No. All right, let's go to backup. Let's go to plan B, right? They open a conference line, they facilitate the conversation, and they keep an active log. In this process, this duty manager actually isn't doing anything to resolve the problem, but it's your most powerful weapon to fix the problem. Okay? While people are running around, they get very myopic, very close to those problems. Having somebody that they can actually pull them out and say, all right, let's communicate, let's coordinate, is going to be amazingly powerful. If you do nothing else, and if you take nothing else away from this talk, implement a duty manager in your company. Try it. Give it a try. Simple, and you're going to find it's extremely effective. Okay? That gives you the recovery plans. Once this is all over, once you're back on the ground, once your servers are back up and running, you have, well, that shouldn't say raise alarms. Okay? Roll it back. Number 1, always be able to roll back. But here's the problem. Can you roll back data? Anybody's tried? It's really hard, right? So your recovery plan also just shouldn't say we roll back our data. In fact, in a lot of ways, that may be the worst decision you make. Because now you have new code out there, things have changed, and your data has changed. So when we roll it back, that data, when it comes back off through your system, is going to cause all sorts of exceptions, errors, problems, and piss off customers, right? Simple rule of thumb, roll code back, roll data forward. When those two are at odds, the only thing you can do is repair on the fly. That's the situation you do not want to be, ever, right? So have a recovery plan and a rollback plan before you release. It's that simple. And that's why. It's because you have two things very much at odds. Post-mortums. Simple. Take a breath. Step back from the situation. Sometimes even for a day. Get help. The help is, what are we going to do to resolve this next time? What are we going to do to address these problems the next time they come around? The first and foremost question you should be asking is, what metrics do we have around this? Let's analyze them. Did we miss something? Will we add more metrics? Is there other ways to understand what's happening? Right? That's where your help comes from. Okay? And of course, once you're done with your postmortems, you're going to have action items. Follow up on them. Right? You don't want to go back off in the air without a way to recover. You don't want to stand at a server back off without knowing if you address some of those problems that got you in there in the first place. But follow up. Right? That's the duties manager's final job, is to make it better for the next sucker that comes around. Okay? Yes?
Many of these measurements you're suggesting take CPU time to slow down the system.
Yes, they do.
How long before the managers say, shut off the measurements?
You know what? Funny that you said that. There's actually a story, but I haven't been able to confirm it, and it comes out of the military. So the military, back about 15 years ago, had set up their first kind of public internet type system. They had ARPANET and stuff like that going on. But they set up their public one, and they started, and then a company came in and said, you know what, we can put in a device that basically can tell you if somebody's trying to hack into your system. Very expensive at the time, a couple $100,000 per device. They got 2 of them, they put them on the system, they turned them on. Alarm started going off like crazy, right? General said, turn it down, take it off, turn it down, we don't want those machines. Very nuisance. All right? Did it solve the problem? Or did it mask it? Mask it, right? When you're talking about, we need to worry about our CPU cycles or our I/O on these machines, you're masking the problem, you're not solving it. So measure it, metrics, metrics, metrics. Pull those metrics off, log them out, find a way, if you need to add another server to do this, it's worth the money. If you add a 3rd server to analyze your data, it's worth the money. Because the only thing you're doing in the context where you're worried about the CPU cycle is you're worrying about internally, am I going to make my boss mad? Your boss should be worrying about, do I have pissed off customers? Okay? So the next thing is accepting the status quo is not an answer, right? It's an excuse, and that's a huge problem. Okay? So rule number 9, code is a liability. Okay? Tell that to a developer and they're going to argue like crazy. You're wrong. Every time you write a line of code, you have a place where you're going to interact with your customers. And they may interact in a way that you don't expect. And that's going to cause a problem. The most perfect code you can find has 0 bugs, has 0 problems, runs almost instantaneously, not instantaneously, but it also has absolutely no features. As soon as you add one feature, you're moving away from perfect code. And the more and more features you add, the further and further away you get. And that's why code becomes a liability. But the problem is, you have to have code have features. That's where the balance comes into play. And the only way to know where your balance is by using effective metrics. Right? Over time, the more features you add, the more users you have, your code becomes crap. So, the more code you write, the more problems you have. The more code you neglect, the more problems you have. Big problem in our industry. We neglect code. We think we wrote it, we ship it, we're done. Okay? The more code you keep, the more problems you have. It's working fine. It's been working fine for years. If you have neglected it, well, we've been reviewing it, it's okay. But if it's sitting around and it's actually not used anymore, that's something else you have to manage. That's extra code you have to keep. Okay? But here's the point. If the code is creating value, you do want to keep it. And you do want to make sure it's really, really valuable and really useful code. So all code becomes bad code over time. Right? Things change. Languages change. Technology change. Approaches change. All of this changes. Who's using the same code they were 10 years ago? Good grief, who's using the same operating system they were 10 years ago? Yeah, there's some of us, right? Who wants to use that operating system, right? Do you? No. Okay. I'll be honest, the company I'm working with right now, we have some machines that are still running Windows 95. Yeah. Right?
OS 400.
Okay, yeah. Right? And it usually comes from a form of neglect. And we've kept around code that we should have past its age. It's zombies. I refer to them as zombie machines. Right? So, rule number 10. It doesn't matter until you ship it. All this stuff we talked about is still coming down to the point where the thing developers really like to do is write code. That's the stuff that brings them in every week, and that's what keeps them busy and up all night through the weekend, is because they're writing amazing, cool code. They get it done and they say, shit, let's go have a beer. Well, or a Coke in Utah. But that's when things start. Right? So I always take a break and a breather with my team. We do a demo and then we ship. But between demo and ship, we take a breather. Because we know that's when things are going to start. Okay? Final thoughts. Yes?
We have another situation you didn't bring up. We call it code rot.
Yes.
We have a project, it's a fairly major project, it gets shelved for 6 months, and you come back and expect it to work the same. But things have changed around it to where it doesn't.
That's neglect. In my mind, that's the same thing as neglect. The code is rotting, but the reason it's rotting is because of neglect. So final thoughts, right? Know the value of your code. Right? Surprisingly, it's not in what you wrote. It's how it behaves in the wild. Have a mental model of your code, right? Remember, what you think is not really what you know. So get to know it. Finally, have an escape plan when all this is done and said. Fewer problems, more value. Please do that.